Last time, we saw that high-dimensional space is mostly empty, with everything crushed against the edges. Now let me prove it with a ball. Take a ball of radius 1. In 1 dimension, it's just a line segment with size 2. In 2 dimensions, a disk with area about 3.1. In 3 dimensions, a sphere, volume about 4.2. It's growing. So surely, in higher and higher dimensions, this ball keeps getting bigger. It feels obvious. And it's wrong. The ball grows for a little while, and then it starts to disappear. Here's the actual volume of a unit ball, dimension by dimension. 1, 2, 2, about 3.1, 3, 4.2, 4, almost 4.9, 5, about 5.26, that is the peak. The biggest a unit ball ever gets is in 5 dimensions. Go to 6, and it drops slightly. 7, it drops more. By dimension 10, it's down to 2.5. By 20, it's 0.02. The volume rises, crests at dimension 5, and then slides all the way down towards 0. The ball is vanishing. Why would adding dimensions destroy the volume? It comes down to the formula. The volume of a unit ball is pi raised to the power n over 2 divided by the factorial-like function of n over 2. Look at the two parts. The top, the powers of pi, grows respectively, but the bottom, that factorial in the denominator, grows explosively, far faster than anything on top. So as the dimension climbs, the denominator simply overwhelms the numerator and crushes the whole fraction down to nothing. The ball loses the race against its own dimensions. Now compare the ball to the box around it. Fit a unit ball snugly inside a cube. In 2 dimensions, the disk fills about 79% of the square. In 3 dimensions, the ball fills only 52% of the cube. 4 dimensions, 31%. By 10 dimensions, the ball occupies 1/4% of the cube. The sphere shrivels into the very center, while the box stays full size. Almost none of the cube's volume is anywhere near the middle. And this connects directly to last time. If the ball in the center is nearly empty, then where did all the cube's volume go? Into the corners. Remember, the corners are the parts that run off toward infinity as dimensions rise. High-dimensional volume doesn't live in the round, comfortable middle. It lives out in the spiky, far-flung corners, the places your 3-dimensional mind can't even picture. The sphere vanishes precisely because the corners win. So that's 14. We watched a sphere grow, hesitate, and then quietly disappear into dimensions too high to see. Brain, 0. Math, 14. We've spent 2 episodes proving that higher dimensional space is strange, empty, and impossible to picture. So next time, we finally try to do the impossible anyway, to actually look at the 4th dimension and see a 4-dimensional cube with our own 3-dimensional eyes. Subscribe, and let's try to see it.